Okay, let's unpack this.
Yeah.
I want you to think about the plumbing in your house for just a second.
Okay.
I know, not the most glamorous image to start with,
Mm-hmm.
but really visualize it. Most of the time, you don't even know it's there, right?
Not all.
You turn a handle, water flows, you flush, and things, well, they go away.
Hopefully they go away.
Exactly. It's unglamorous, it's hidden behind the walls, and honestly, you only notice it when something goes catastrophic.
Right, when there's a leak or a burst pipe and suddenly your kitchen is a swimming pool.
But without that plumbing, the house basically doesn't function. It's just a box.
It is the essential infrastructure of daily life. And it's a perfect metaphor for what we're getting into today.
It is. Today, we are talking about exactly that, but for software. We're diving into the world of software plumbing.
Mm-hmm.
We're looking at that, that essential work of connecting pipes and ensuring data flows correctly from point A to point B without leaking all over the virtual floor.
And we have source today who really embraces that identity.
We do. We are looking at a really fascinating source today. It's a technical journal, a blog, technically, but that word feels a little too casual for this.
It does, yeah.
It's from a developer known simply as Ang, and he describes himself in his bio as an old software plumber.
I love that.
And the vibe is distinct, it's disciplined, it's quiet, and it is incredibly prolific.
Prolific is kind of an understatement. We are looking specifically at an entry published on February 4th, 2026. It is titled Notes on Haskell Programming, Part 49.
Part 49. And that's just the Haskell section. That number, actually, you'd stop me in my tracks.
Right.
Part 49 implies a long-term relationship with the subject.
Yeah.
This is not a learn Haskell in 24 hours post. This is a chronicle.
It is. And because it's Part 49, it lets us zoom in on a very specific, very common hurdle. We aren't doing what is a variable today.
Yeah.
We are looking at how to bridge the gap between a simple data type, just a container for information, and a command line interface, or CLI, parser.
Right. So to set the scene, imagine you're building a tool. In the source, Ang is building something called XS2BBook.
Right.
It's a converter that takes Chinese text novels, so TXT files, and turns them into ebooks.
Which is such a classic scratch-your-own-itch kind of script. You have a problem, you write a little program to fix it.
Exactly. So Ang has his blueprint. He's got a data structure ready to hold his arguments, like the file name. But here's the problem, and this is the core of our deep dive today.
Okay.
His parser, the thing that listens to what the user types in the terminal, doesn't know how to put data into that structure yet. It's like having a box and an item, but they're in two different dimensions.
And that is where things get really interesting. Because to solve this, to bridge those dimensions, we have to talk about one specific, slightly alien-looking operator.
Oh, yeah.
It looks a bit like a TIE fighter from Star Wars. It's a $ sandwiched inside angle brackets.
I love that symbol. It looks very hacker chic.
Yeah.
But I promise, by the end of this, you're going to look at that symbol and think, yes, that is exactly the tool for the job.
It represents a concept called lifting, and once you get it, it really changes how you visualize data flow.
So let's get into the code. We're looking at Ang's work. He started with a very simple data definition. He's defined a type called args.
Right. The code in the notes is just data, args, input file, that file path, and it derives show and EQ, which just lets us print it out and compare it.
It's the simplest box you can imagine. It has one job, hold a file path. And a file path in Haskell is basically just a string, right?
Correct. It's just a string of characters that points to the file, like tmpnovel.txt or whatever.
Okay, so we have the box. Now we need to fill it. We're working in a file called XS2EBook CLI.hs. We're using a library called optparse-applicative.
Which is pretty much the standard for parsing command line arguments in Haskell. It's powerful, it generates help text, handles all the flags, but it's very strict about types.
And that's where the friction comes in. So walk me through the naive approach. If I'm a beginner or even just a tired developer who wants this to just work, what do I try to do?
Well, you look at the pieces you have. You have your constructor, args. That's a function. It takes a string and gives you an args object.
Simple enough.
Then you have the library functions argument. The docs say it grabs the argument from the command line.
So logically, I think, hey, args function, here's the argument from strargument. Put it in the box.
Exactly. You just try to jam them together. You write args, strargument. It feels like it should work.
But the compiler, GHC, just screams at you.
It refuses to compile. And the error message Ang shares is a classic. It says, couldn't match type, parser 0 with, char.
Couldn't match type, the bane of every Haskell developer's existence.
But also their best friend eventually.
Eventually. But let's break that error down. What does it actually mean? Char is just a list of characters, a string.
Right, that's what ours is waiting for. It's standing there with its hand out saying, give me the text.
But strargument doesn't give you a string.
No, not yet. It gives you a parser string.
Okay, and this is the crucial distinction. What is the difference between a string and a parser string? Because in my head, I know the parser gets the string, so why can't I just use it?
Think of it this way. The args constructor lives in the world of immediate values. It wants the text novel.txt right now. But the parser it's a set of instructions. It's a promise.
A promise.
It says, I know how to get a string from the user, but I haven't actually done it yet.
So it's like a recipe.
Exactly. Strargument is a recipe for a cake. Args is a hungry person who wants to eat a cake. If you hand the hungry person a piece of paper with instructions, they can't eat it.
That is a perfect analogy. The hungry person, the args constructor, cannot eat the paper. The types don't match. You have a recipe for a string, but you need a string.
And that's the mismatch. The args function is stuck in the real world, and the data it needs is trapped inside this parser context, this recipe world.
So how do we fix it? Do we, run the recipe first and then hand over the finished cake?
You could try, but that usually gets messy. The Haskell way is different. Instead of trying to pull the cake out of the recipe world, we send the hungry person into the kitchen.
Okay, explain that.
This is where our hero arrives. The operator. The TIE fighter.
The TIE fighter.
In technical terms, this is the infix version of funcmap. It stands for functor map.
Let's maybe not get too bogged down in the functor jargon because that can scare people off. What does it do here?
Eng puts it very simply in his notes. He says, we are lifting the args function into the parser context.
Lifting. I like that visual. It feels like you're lifting something heavy.
Think of the parser as a sealed room where the baking happens. You can't reach in and grab the cake. But you can use $, to teleport your args function inside the room.
So we aren't extracting the value. We are injecting the function.
Precisely. You tell the parser, hey, follow your recipe, get the string from the user, and then, while you are still inside that room, immediately apply this args function to it.
So the worker inside the room bakes the cake and then immediately puts it into the args box before it ever comes out.
Exactly. We are mapping the function over the context. So the code changes from the broken version to args strargument.
And suddenly, the types align. Because the result of that whole expression is no longer a type mismatch. It's a parser args.
Yes. We started with a parser string, and by lifting the args constructor, we transform the whole thing into a parser args. Now, the library handles all the messy work in POP. It drops the data right into your nice, tidy args box.
It's so elegant. It really is. It turns what feels like this huge problem, 2 different dimensions, into a one-character solution.
And this is why Haskell developers love these operators. You can compose these complex pipelines without writing a ton of boilerplate code to unwrap and rewrap values.
It's all about keeping your domain model, your args, pure and simple, and letting the tools handle the translation.
And that reflects the broader philosophy of the software plumber.
Yes. Let's pivot to that because the code is cool, but the context around this source is honestly just as fascinating to me.
It really is.
We're reading Notes on Haskell Programming, Part 49. But then you look at the sidebar of Eng's site.
I was looking at that. It's incredible.
Dude, listen to this. He has notes on fish keeping. Any guess what part he's on?
I saw this. It's part 187.
Part 187, The Nostalgic Encounter. And it doesn't stop. Notes on gardening.
Part 797.
797, The Affordable Elegance. And Notes on Photography, Part 228.
This paints a very, very specific picture of who is teaching us this code. This is not a move fast and break things kind of developer.
Right.
This is someone who values slow, steady, iterative accumulation of knowledge.
A plumber.
A plumber. Someone who maintains systems, whether that system is a planted aquarium, a tropical garden, or a Haskell codebase. It's all about tinkering.
The sidebar actually says that. Night-long tinkering with free Libre and open source software.
Tinkering is the key word. It implies this cycle of observation and adjustment. In the source, he actually shows us this. He talks about testing his assumptions in the REPL.
Right, he shows that screenshot of his terminal.
He shows a session where he tests my args equals args, tmpnovel.txt, and confirms it works. Then he tests the broken parser version to confirm it fails.
It seems so trivial, though. Why show us that? We know the box works.
Do we? Or do we think we know? That's the plumber mindset. You check the seal on the pipe before you turn the water on.
Oh, okay.
By testing args in isolation, he proves his data model is sound. If he tried to do everything at once and it failed, he wouldn't know where the bug
It's
was.
the scientific method applied to coding. Isolate the variable.
It is. And think about the connection between fish keeping and Haskell. In an aquarium, you have to balance the water chemistry, right? You can't just dump stuff in.
Right, you'd kill the fish.
You have to respect the system's rules. And in Haskell, you have to respect the type system. You can't just shove a string into a parser. You have to lift your functions. It's the same discipline.
That is such a cool connection. It makes the operator feel less like abstract math and more like, I don't know, using the right fitting on a pipe.
It is the right fitting for the pipe.
Let's talk about the application here, because there's a question a lot of listeners might have. In the source, Ang provides a diff of his changes. He replaces parse CLI, IO, with parse CLI args.
This is a subtle but really important shift. Originally, the parser returned nothing IO, means do some stuff and finish. But now it returns IO args. It returns data.
But why is that better? Why go through all the trouble of defining data args if you only have one file path? Couldn't you just pass the string around?
You could just pass the string, but that's the duct tip solution. By defining args, Ang is future-proofing.
How so?
Right now, XS2 ebook only needs an input file. But what happens tomorrow when he wants to add a flag for output format? Maybe .epub and .mobi. Or a flag for font size.
Okay, I see where you're going with this.
If he was just passing a raw string around, he would have to go find every single function that touches that string and rewrite it to take a string and a format and a font size.
Which is a nightmare. That's how you introduce bugs.
Exactly. But because he has wrapped it in args, he just adds a new field to the record. The rest of the program just passes the args box around. The plumbing is robust. It can handle more complexity without bursting.
So part 49 isn't just about fixing a compiler error. It's about setting yourself up for success in part 50, 51, and 52.
It's about building a system that is easy to reason about. When you see parse CLI IO args, you know exactly what that function does. There's no ambiguity.
I love that. He goes back to his bio, the old software plumber. It implies he's seen enough leaks to know how to prevent them.
And he knows that clarity is the best waterproofing.
So to summarize the technical takeaway, if our listener is sitting there, maybe learning Haskell, maybe dealing with types in Rust or Swift, what is the core lesson of the operator?
The core lesson is, don't fight the context.
Don't fight the context.
If your data is wrapped in a parser, or a future, or an option, or a list, don't try to prematurely rip the value out. That's the square peg in the round hole.
Right.
Use the tools the language gives you, like map, fmap, or dollar to send your logic to the data.
Bring the worker to the construction site. Don't try to bring the building to the worker.
That's a great way to put it. It keeps your code safer, cleaner, and more composable.
And it prevents those scary GHC error messages.
Well, it prevents that specific error message. You'll find others.
True. There's always another error message waiting.
But that's just part of the process. That's just finding the leaks in the pipes before you turn the water on full blast.
That is the wisdom of the old software plumber. Isolate the variable. Check the seal. Then move to the next pipe.
And only then, when you're sure the pieces fit, do you use dollar to weld them together.
So here's a challenge for you, the listener. We all have those scripts. You know the ones I'm talking about. The maintenance scripts, the little things you wrote 3 years ago to automate one task.
The ones held together by duct tape and hope.
Exactly. The ones where you have to remember, okay, the first argument is the file, the second is the date, but don't put a slash in the date or it crashes.
I have way too many of those.
Ask yourself, are they fragile? If you needed to add a new feature to them today, would everything break? Or are they built with the structured discipline of a Part 49 journal entry?
Are you just passing raw strings around, or have you defined your args?
It might be time to put on your plumber's belt, grab your wrench or your operator, and do some retrofitting.
Future you will definitely thank you.
And hey, if the code gets too frustrating, if the compiler just won't cooperate, maybe take a page out of Ang's book. Step away from the screen. Go tend to the garden. Go watch the fish.
Keep tinkering.
Keep tinkering, whether it's in Haskell, the garden, or the aquarium. Thanks for diving in with us today.
Until next time.